Alright, today is the last of the 7.3 videos. We're talking about synthetic division and the substitution property with polynomials. And so yesterday we looked at long division of polynomials. So we did this problem. It was x to the third plus 3 divided by x minus 1. And we ended up with x squared plus x plus 1 plus 4 over x minus 1. And so this was the long division method. So today we're going to look at the synthetic division method. And synthetic division is kind of weird, but it works. And so if we want to do x to the third plus 3 divided by x minus 1, what we do is we start by writing down the coefficients of the top one. So actually, we're going to take that back. We're just going to make a little backwards L up here. We're going to put something in this box. And now we write the coefficients of this. So the coefficients are 1, and then 0 for the x squared, 0 for the x term, and then 3 for the constant term. Alright, and then leave some space. Draw a line. So really we're just learning a procedure here that will help us divide polynomials a little bit easier. And then we're going to put another little box down in the corner here, and we'll figure out what that is as well. So we started by writing down the coefficients, and now what we write in this box is what makes the number we're dividing by, or the polynomial we're dividing by, what makes this 0. So what would make this 0 if we did x minus 1 equals 0? We add 1 to both sides and we get x equals 1. So we'd put a 1 up here. Okay, so now the next part of the problem is just kind of a repetitive procedure. So we start by bringing down the 1. And now we take the number in the box, 1, times this 1. So 1 times 1 is 1, and we place that up here. Now we don't subtract, we add these two numbers. 0 plus 1 is 1. Alright, now we repeat. 1 times 1 is 1. We place that number up here. 0 plus 1 is 1. And then repeat that again. 1 times 1 is 1. Place that here. 3 plus 1 is 4. So now, what the heck does this mean? So hopefully it's clicking now. This 1 is the 1 for the x squared. This 1 is the 1 in front of the x. This 1 is the constant. And the 4, this is the remainder. Cool. So our answer is x squared plus x plus 1 plus our remainder of 4 over x minus 1. So to me, this method is much easier. It's not as familiar because we're used to dividing numbers using this method. So the synthetic division is kind of confusing at first, but once you get it down, it's way, way easier. Now the only problem is you cannot do, we're not going to learn how to do, synthetic division where if you divide by like an x squared term, we're not going to do any of those. So synthetic division only works, we can write this up here, it only works when dividing by a linear polynomial. Okay. So let's try another one. So we've got 2x to the fourth plus 15x to the third minus 50x squared. So our first step, we're going to put in a little box. And we're going to write down the coefficients of this polynomial. So it's going to be 2, 15, negative 50, negative 195, and positive 108. And then we draw our line. We make our little box for our remainder. This is always going to be our remainder. And then up in this box, we put whatever makes this 0. So -9 would go in the box. Alright, so now we go back and we do the same procedure as we did before. We drop down the 2. -9 times 2 is -18. 15 plus -18 is -3. And then we -9 times -3, that's positive 27. -50 plus positive 27 is -23. Alright, -9 times -23. Let's see, that would 10 times 23 would be 230. So subtract 23, so 207. So it's going to be positive 207. So when we add these two together, 195 and 207, that's going to give us 12. Positive 12. Alright, and then -9 times 12, that is -108. And our remainder is 0. Okay. So, our answer then, when we take this divided by x plus 9, we get, let's see, this is going to be our constant term, that's going to be our x term, that's going to be our x squared term, and this will be our x to the third term. So it's going to be 2x to the third minus 3x squared minus 23x plus 12 with no remainder. So when we divide these, we get that. So what that means is if we take this times x plus 9, we get this big polynomial. The other thing that it tells us, since the remainder is 0, that tells us that it crosses the x-axis at -9. So that's kind of a big deal here in this chapter. If the remainder is 0, we know that this is a factor of that polynomial. And so that means that the graph would cross the x-axis at -9. Maybe we could write that down. Crosses x-axis at -9. Okay. So that's it for synthetic division for now. Let's look at the substitution method. So this is a way to determine if something is a factor of a polynomial. So we've done that. In long division, if there's no remainder, if the remainder is 0, then it would be a factor of the polynomial. So x minus 2 would be a factor of this if the remainder was 0. In synthetic division, same thing. If the remainder is 0, then x minus 2 is a factor. With the substitution method, it's a lot like synthetic division, it just looks a little different. So what we're going to do is we want to figure out what the 0 of x minus 2 is. So x minus 2 equals 0, that would be 2. So that's going to make this thing 0. So we're going to put 2 in for x into every one here. So it would be, I'll change colors up here. It would be 2 times 2 to the third plus 2 to the second minus 13 times 2 plus 6. And what we're looking for here is if when we plug the 0 in for this, if we get 0 for an answer, then that tells us that this is a factor of that. So now we have 3 methods to finding if something is a factor. So let's do this. 2 to the third, that's 8. So 2 times 8 is 16. 2 squared is 4. 13 times 2 is 26. And then plus 6. So 16 plus 4, that's 20. Negative 26 plus 6 is negative 20. So 20 minus 20 is 0. So that's great. that means that x minus 2 is a factor of 2x to the third plus x squared minus 13x plus 6. And it also tells us that it crosses the x-axis at 2. So this graph, I don't really know what it's going to look like, but I know at 2 it's going to cross the x-axis somehow, which is kind of cool. So I don't know, it might look like that. Alright, so that's the substitution method. So the idea here is if x minus a is a factor of a polynomial, p of x, then if you do p of a, that's kind of what we did. We did x minus 2, we just did p of 2. If that's 0, it's a factor if it's 0. If it's not equal to 0, then it's not a factor. And moreover, if it is a factor, then that means it crosses the x-axis at a. Cool. I think the period's supposed to be inside there. Alright. And that's it. So that's it for today. Hopefully the video was short enough for you. Your assignment is at the bottom of the note sheet.